Hi, my name is John Rinaldi. I'm in the video production area of real-time automation today, and we're going to talk about electrical interfacing of different kinds of transmission systems. So, in the last video I talked about UARTs and serial communications and how UARTs create a stream of bits that has to go out whenever you're sending data off. Even if you're sending it to another computer, you're sending it over the internet, over CAN, over Modbus, doesn't matter. Today we're going to talk more about now electrically what happens. So anytime we've got some kind of processor, and that processor has a UART, which in my last video I said was universal asynchronous receiver transmitter. They all have UARTs for serial communications. That thing is going to send out some bit stream. So some set of ones and zeros. Now that bit stream is just a set of electrical signals that are referenced to the electronics of the microprocessor. In today's electronics, these things are typically going to be 3.3 volts, either 0 or 3.3 volts to send the bits out. Well, that's not what goes out on a serial communications network. It doesn't go out over CAN or anything else. So there's something that has to take that and turn it into an electrical signal that can be transmitted from one place to another. A 3.3 volt signal wouldn't get very far if you tried to transmit this over, say, 200 feet of cable. There's just not enough power there. There's not enough power in the transmitter of the microprocessor to get that data that far. So what we have is some kind of physical interface. And you could call that, generally that's some kind of phi for physical interface. So what that does is takes in the bit stream from the microprocessor, 0, 1, 0, 1, whatever it is, and sends it out as an electrical signal at the voltage that's needed to go on a wire and go so that it can be received by one or more other devices someplace else on the wire. Now there's a couple of different standards here that I want to talk about. So let's talk about first is what's RS232? What's interesting about these standards, that's an electrical standard for the drivers, the physical drivers that put these electrical signals out on the wire. RS232, the characteristics of RS232 are point-to-point communications. It's designed to not be the drivers, the electrical drivers in here are not designed to be sent to lots of devices. They're designed to be sent to one device. Typically in an RS232 system, you have a transmitter, a receive line, and a ground. And that goes to a receiver, a transmitter, and a ground on the other side. Okay, what you see here is I connected the transmitter to the receive to the transmitter, and the ground to the ground, or common to common. This is called a crossover. This is a crossover cable, essentially. What's happened here is because, of course, when data is sent on the transmitter, it's got to go into the receiver on the other side. Very clear. RS232. This is the first thing you have. Now there are some control signals. There's clear to send, data terminal ready, a bunch of other control signals that get involved in this too. Don't have time to discuss those today. But the basics of RS232, point to point. The transmitters are generally designed to only go maybe 50 feet. Another characteristic of RS232. So we're talking about short distance communications. Here's the big problem that you have with RS232. So we've got one device here, got another device here, and we connect up these three lines. So if this guy is sending a 1 out, that's referenced to the common. So essentially, if the receiver is going to measure this voltage between here and between here. Fine. Okay, you say that's fine. What's wrong with that? Well, the problem is when you get noise. So if there's a little bit of noise in this system, maybe there's a motor nearby. In an industrial environment, we're going to have noise because we got lots of things going on and off. Every time you generate something on and off, there's some kind of electromagnetics. Those things get picked up by these wires, and that could force the signal down. So now, you know, it's kind of iffy. That thing that we thought was a 1 is now in reference to this as well. Is that going to be picked up as a 1 or not? Yeah, it's a problem. You know, the more noise there is, the less number, and we talked about in my last video that there's a particular number of data bits you're supposed to get, there's a particular parity bit, there's a number of things. This guy's probably not going to receive this byte string because of that noise. So with RS232, it works great for low noise environments, things that are connected when they're close together, but it's not at all good for noisy environments. So in our factory environment, like the stuff that RTA makes, very seldom is RS232 used. It's only used when we're pretty confident that we've aren't gonna get a lot of noise, aren't gonna see a lot of errors. If you do, then we have to do something else. And with that other thing that's typically used is RS485. So let's take a look at what characteristics of RS485. So with RS485, the big thing with RS485, it's multi-drop. It's like this. Multi-drop. That means that there's one guy transmitting and everybody else is listening. One transmitter and receivers. That's the big differentiator for RS485. This is what's called half duplex transmission. Half duplex because you only have one communication going out at a time. The transmitter sends something out. All the receivers are listening. The receiver then gets a message. He becomes a transmitter, sends something out while everybody else is listening, including the old transmitter. So this is half duplex communications. With RS232, we had full duplex communications because we had a receive and a transmit line. The one transmitter from the first unit could be transmitting the same time that the transmitter from the other guy was transmitting because the lines weren't crossed. Here we're using the same lines. It looks like this. We've actually just got two lines. We've actually just got two lines that connect all of our devices up. So initially, this guy's the transmitter. In most of these systems, they're going to be master-slave. The transmitter is going to orient these lines, and his drivers, his electrical drivers, are going to send data out while those guys are in listening mode. Then there's going to be a turnaround time, and the turnaround time is one of the places where things get screwed up, because this guy's going to send the last bit. When he sends the last bit, he's now got to turn his drivers around and start listening. If these guys send before he turns his drivers around and goes into listen mode, he might miss the first bit. He misses the first bit, all bets are off. Nothing's going to happen. So that's one of the deficiencies of getting an RS485 network together, is that you got to get that turnaround time right. Now here's the big advantage to RS485. So what's going on here is initially this guy's going to transmit, those guys are going to receive and say this guy got the message. Well, then what happens is he turns his drivers around to become a receiver. This guy turns his drivers around to become a transmitter, and now the same process happens. He sends, and both these guys are listening. And typically there's some kind of address in the message so they know, oh, this is for me. And this is exactly how Modbus works. The master device is going to send a message out. All the slaves are going to listen. The slave that gets the message is going to say, oh, that's for me. He's going to go into transmit mode. He's going to go into receive mode. And the master is the only one that's going to actually process the message because the other slaves realize that this is a reply message. Okay, but now how does this work with we saw at RS232 that there was this bad problem with noise. Well, here's the interesting thing about this. We get noise on here. get a spike. What happened? We still have the same amount of distance, the same amount of voltage differential between both lines. Even though there's a motor or something else caused a spike in the communications line, induced a voltage, it gets induced in both lines the same amount, so nothing happens. If this was a 0, it stays a 0. If it was a 1, it stays a 1. So it cancels out the noise because it gets induced in both of them. So that's a huge advantage of 485, noise immunity. Now the other thing that has to happen is this, because this can go a lot longer than RS232. These drivers are built to go, because you got multi-drop connecting lots of devices, 1,000 feet. But what happens electrically is you get reflections on this. When this guy sends his message out, it can reflect the bits back toward him. And he can say, oh wow, I'm getting a message back right away. Well, to get around that is you put termination resistors here. At both ends of the network. Never in the middle, always at the ends. The termination resistors essentially eat up that excess, and stop that bits from being echoed. So there's no more echo and makes it work right. Now this is typically 120 ohms or something on each end. Now a lot of people get that wrong, and one of the things that really screw this up is sometimes you buy a device and there's a built-in resistor inside of it. Well, that screws everybody up, because if you put that device in the middle, now sometimes there's a switch or a jumper to get rid of that. Well, that doesn't work real well. So hopefully you're not going to get a device that has a resistor in the middle. So that's the difference between full. So this is half duplex communications. RS230 was full duplex communications, and I think that takes care of my brief explanation of RS232 485 and how we go from bits that are generally 0 to 3.3 volts at the processor voltage level, some kind of phi that's going to send out, that has drivers that's going to send out data on 232 and 485 on those various kinds of serial networks like Modbus. So thank you very much for listening to another one of my videos, and I hope you'll stay tuned for more videos in the future.
Beware the alligators!